Hello to you. My name is Jessie Johnson. This is Flat Earth, Globe Earth, Perception, Perspective, Their Differences. Flat Earth Truth. This is part 1 of 3 parts. Paragraphs 1 through 8 shall be used here, and paragraphs 9 through 15 shall be used on part 2. Part 1 shall be 1 through 8. Part 2 shall be 9 through 15 paragraphs. If it's not truth, it's not flat earth. Perception and perspective come in 2 broad categories. 1, mechanical. 2, social. Only mechanical perception and perspective shall be talked about. Watch this video to the end, and in completion, all 3 parts. There's a secret within it. These are the definitions of perception and perspective. You may stop the video at any point you wish to absorb more the information. To begin, perception and perspective has 2 major parts. 1, mechanical. 2, social. Definition: perception. 1, ability to become aware of something via the senses. 2, a way of regarding, comprehending, understanding something through impressions and meaningful information. 3, interpreting sensory stimuli. The closer to actuality, the better. 4, the process of getting, receiving, and collecting data and info. Interpreting, selecting, organizing sensory info. 5, stimulation of the senses. Organizing info, interpreting info, evaluating info. Use of memory and recall of info. Judge and assessment of surety of info. Making a verdict on info. 6, perception is influenced by heredity, needs, peer, groups, interests, expectations, bias, prejudice, stereotyping, perceiving actuality. Definition: perspective. To give a right impression of the distance, height, width, length, depth, position in relation to all other elements. 2, a way to see things, observe elements, characters, events, contrasts, happenings, etc. 3, mental view prospect, a visible scene, an interrelationship of wholes and parts. 4, the capacity to view things in their true relations to each other or relative importance with each other. 5, appearance to the eyes of objects, processes, and things in respect to their relative distance and positions. 6, representing the correct curved, linear, planar, volumetric, and spatial relations of objects. 7, representation in drawing, paintings, visual arts using straight lines, mainly converging to give depth via vanishing points. 8, techniques of depicting points, lines, planes, volumes, and the like in relations on a surface. We'll go to paragraph 2. There's a mechanical limit to perception and perspective. There's a perceptual and perspective mechanical limit when dealing with human senses. If the earth were ball-shaped and you are at sea level, because of its large size, it would appear flat. As you gain altitude and height above its surface, it would not stay flat, and the surface would not stay parallel to a 90-degree line drawn to that altitude line above that surface, which is a straight line drawn from the center to your position as an altitude. Instead, because you're on a ball-shaped object, the surface, its horizon, and its atmosphere would curve downward away from you and the 90-degree line to the altitude line. It wasn't flat to begin with, such as this. This is basic geometry. Basic geometry. This is 1,000-mile segments. 1,000-mile segments. Take one of them and put it up here. Becomes the altitude line. This is 90 degrees to the altitude line, this line here. These are the tangents. Tangent points. Tangent points. The tangent points. A tangent is a curved or straight line that touches a circle at one point only. It is physically impossible to see beyond this point. Why? Because the surface curves away. This is the chord line, this straight line. This chord line connects both tangent points. The chord line connects both tangents. A chord line connects 2 points of a circle from within the circle, from inside the circle. If you're 1,000 miles above a 24,901 mile circumference sphere, you must start looking down to see the horizon. Anyone telling you different is dealing in false math and is lying to you. We'll go to paragraph 3. Whether you go up 100 feet or 100 miles or more in altitude, you must look downward from the 90-degree line to the altitude line. You must start looking down from the 90 degree to the altitude line, downward toward the surface to see the surface. You even here, even if a tangent line is touching the surface, you still must start looking down to the surface as you go above it. Now, to see the horizon and the surface. This is to see the horizon and the surface. Both are curving away from you at every point on the sphere. Since the ball Earth is considered 24,901 miles in circumference, it would start curving away instantly and its horizon continuously as you go up, until it's not seen at all, while looking straight along the 90 degree to the altitude line. If you're looking straight along this line right here, you would not see this down here. You'd see no atmosphere, no horizon, no ocean or land. They've curved downward under you. There's only 2 ways to see the Earth's external curvature from above it. This is the external curve. This outer circle is the external curvature. The external curvature. Now, once again, this is basic geometry. It is physically impossible to see the external curvature of a 24,901 mile circumference sphere 1 mile to 1,700 miles distance from it. You must be specifically oriented to the sphere, such as a circumference sphere, such as a 1,750 mile altitude line is drawn here. 1,750 miles altitude line is drawn here to this smaller circle. This is the 90 degree to the altitude line right here. You must be specifically oriented to the sphere. You must look 45 degrees from the 90 degrees to the altitude line to see the external curvature. You must look 45 degrees here to the 90 degree altitude line, this line right here. You must look 45 degrees to it to see this part right here of the Earth, the external curvature, if you see any at all. The other way is to be at least 15,000 to 30,000 miles away from the surface. It must be, this is 5,000 miles away, 10,000 miles away, and 14,000 miles away at the bottom here. This is basic geometry. This is the tangent to those points. The tangent to the curve, to the curve. And this is the chord line which attaches both. This is all the surface you would see. You would not see this whole surface. The whole surface can only be seen over here at the diameter line. You would not see its whole surface. There are 2 ways to determine the Earth's shape externally from above it. 1, 15 to 30,000 miles away from it to see about 98% of the surface. 2, 1,750 miles and to look at it at a specific angle. Now I'm going to show illustration B once again. If Earth were a sphere, which is represented here with this giant circle, if Earth were a sphere, then at every single point on the sphere, Earth is curving away from you, no matter where you're standing, lying down, or sitting. There's a physical limit to how much and how far you can see. It is impossible to see an external chord section. This is a chord section right here. This straight line with this hump on the top. If you could take that part out, that would be a chord section. And this is here, the straight line is the chord, of course. An external chord section of the earth, unless you are far from it. If you're 100 miles above around earth, here's 100 miles right here. 100 miles above the earth right here. And you must look down to see the surface. Here's the tangent points. The tangent points. Here's the 90 degree to the altitude line right here. This is basic geometry. Now, if you're 100 miles above around Earth, draw parallel lines at 90 degrees to the chord line. Here's the chord line right here. Draw parallel lines to it. Parallel line 90 degrees to it. Draw a circle between them. Now draw a circle between the parallel lines. This here's the visibility limit. This is all the area you can see at 100 miles up. You cannot see this gigantic ball. All you can see is this much. That is the maximum amount of surface you can see. It's impossible to see beyond it because the surface is curving away from you. We'll go to paragraph 4. Apparent horizons on a ball earth don't exist. It is false, produced by false scientists with false math to fool their own dumb selves and the gullible. This falsehood smothers real science. There are 4 types of horizons: land, water, air, platform. If a ship is on the ocean on a ball earth, it will disappear, not because of perception or perspective limits, but because it has gone over a physical curve and cannot be seen no matter how high you go. There is no apparent horizon at eye level on a ball earth, because the horizon curves below the 90 degree to the altitude line as you go up. We'll go to paragraph 5. Since an atmosphere on a ball earth is 12 to 15 miles thick and contains about 98% of all the air, you'd be 85 miles above it if you're at 100 miles altitude. If you looked straight out along the 90 degree to the altitude line, you'd see only blackness of space and no horizon and no earth. Look straight along this line right here, straight along. You will never see this here if you look straight along. Even if you're 100 miles above it, if you look straight along this line, you'd never see the earth below it. You're too high above the surface, that's why. On a flat earth, you would see the horizon at 100 miles up. The flat plane ground is parallel 100 miles up at every point above the ground to the 90 degree to the altitude line and stays parallel no matter how high you go up. Word of note, this is a word of note, never trust GoPro cameras or fisheye lens cameras. Never. These cameras are built specifically to distort Earth images to look circular when in fact is flat. Only trust cameras that show things the way the human eye sees. Now, to get back to the business, there's a difference between a thing moving parallel away from you and a thing moving curving away from you. We'll go to paragraph 6. By contrast, for instance, on a flat Earth surface, if you're at sea level, it will definitely look flat. These are pictures of water, air, and land horizons at different altitudes, from 2 feet to 40,000 feet up. Now, 75 miles altitudes are the highest genuine photographs that can be found. Everything else is a lie. Look at this photograph, please. This picture, better yet. You see the horizon? You see the people standing? See them? You see the horizon don't go up much more than 2 feet or so? 2 feet across their waist and their knees and legs and so on. That means the camera is approximately 2 feet above the beach. That's how high this horizon is. Look at this one. You have more area showing, more more span of view showing. Therefore, this picture, even though it's on the beach, this picture was most likely taken by from somebody 5, 6, 7 feet tall, as you can tell. Look at this one. Once again, the horizon is pretty high. That means a person that's 5, 6, or 7 feet tall with that camera took this picture, because you can see more area, and therefore the horizon seems to rise with your eyes and the camera lens level. Once again, here's the horizon at this tree level. See this tree up here above the beach? Here's the beach down here. Here's some gigantic rock, whatever it is, with some trees on top of it. Well, the horizon is right here at the tree level. That means the person who took this picture is at least 75 feet above sea level to have taken this picture, because this horizon is seeming 75 feet above sea level, seemingly rising with the eyes. Look at this one, please. Now, here's the sea, here's the horizon, here's the trees on top of hills, because here's the houses and so forth on top of hills. That means the person who took this picture is as high as the trees themselves. As high as the trees themselves, because the horizon is telling you it's high as the trees themselves, which is about, I guess about 150 feet, 200 feet above sea level, something like that. Look at this one, please. Now, this one here, the horizon is above this bridge, which is probably a train bridge or whatever it is. But nonetheless, here's the pylons or whatever it is about maybe 200 feet high already, and the bridge. So therefore, this picture, whoever took this picture, is probably about 250, 300 feet above the sea line, and can see. And therefore, the horizon is approximately 350 feet above the sea, the beach, and so forth, because you have a greater expansion of view, a broader expansion of view. That's why the horizon seemingly rises with the eyes, because as you go up, you have a greater expansion of view. Now, here's the horizon right here. Here's the horizon above these low mountains, a little bit above these low mountains, which implies that the person who took this picture is also standing on one of these low-level mountains above this house and above the trees and so forth. Here's the trees and all and so forth, and here's the horizon here, which is a little bit above this, which is probably, from looking at this low-level mountain, is probably 300 to 400 feet up. So the person took this picture about maybe 450, maybe 500 feet above, because the horizon is 500. Perhaps about 500 feet showing, because you have a greater expansion of view, which makes the horizon seemingly rise with the eye level. Here's another one. Now, this one here is a land horizon. Probably taken from this one of these low-level mountains. Probably taken from on top of one of them, or a helicopter or something like that. Once again, look at the horizon. The horizon rises with the eye level. That means however high this person is taking the picture, which is probably 450, maybe 500 feet above ground, something like that. Looking at this, and therefore the horizon rises 500 feet above ground with the eye level. Not physically, of course, but seemingly. Now, here's the Golden Gate Bridge. The Golden Gate Bridge is here, and therefore the Golden Gate Bridge is about 700 to 750 feet above water. And there are about two of these. This is the water line. Here's the water line, and there's about 2 Golden Gate Bridge lengths going up to the water line. So therefore, this picture was taken probably about somewhere between 1,300 and 1,400 feet above water. And therefore, the expansion of view, which rises with the eye, is about 1,400 feet with the camera. Look at this one. Once again. Once again. Once again. You see this building right here that I'm pointing to? And here's the water level. Here's the water level way up here, way up here. And all of the expansion of view, all of this stuff is expansion of view. All of this stuff is expansion of view. And you have this building right here, which is 1, 2, 3, 4, 5. So this person in taking the picture is probably about 500 feet, maybe 600 feet above the ground, taking this picture, because this is about 500 to 600 feet of expansion of view that goes up with your eye level as you keep on going up. Your view keep on expanding. Look at this one. This one here tells you, right here, that it is 22,330 feet above water, above sea level. This statue up here is 2,330 feet above water, above land, above the sea. Here's the horizon, in the horizon, right here, the horizon. That means the horizon. That means the person is seeing a great deal of horizon. At 22,330 feet, the horizon has risen to his or her own eye level at 2,330 feet up. Look at this one. Here's a mountain. Here's the beach. Here's the mountain, and here's the horizon. The horizon goes straight across to the tip of this mountain right here. Tip of this mountain. That means if the person was standing on top of this mountain, this is what they would see as this mountain goes around here. And the person, whoever has the camera taking the picture, let's see, I guess this mountain right here is about, I don't know, from the looks of it, about 300, maybe 350 feet up, maybe 400 feet up. Well, 400 feet up gives you this much expansion to the horizon. 400 feet of expansion. 400 feet of seeming eye level rise of the horizon. Here the person is above these green mountains, and here's the horizon right here, straight across. Even above these green mountains. The horizon is a little bit above these green mountains. A little bit above this green mountain. That means the person who took the picture is also above these green mountains. And here's the beach. So this thing here is probably about 900 I guess, feet above the water, giving you a 900 feet expansion of view to the horizon, which rises with the eye level because of expansion of view. Because of expansion of view. But there is a difference between a round surface. This is part of paragraph 6. There is a difference between a round earth and a flat earth, of course. The surface of a flat earth is parallel to the 90 degree to the altitude line. The horizon seems to rise with the eye and camera levels. There's a reason for this, of course. On a sphere, the surface is curving away from that. And this does not happen like it happens on a flat surface. Number 7 paragraph 7. If you're on a beach watching a ship go away on a flat earth, first the bottom disappears, then the top. This is not because the earth is round, but because the limit of the eyes. The moment the ship vanishes, take a zoom lens camera and bring the ship back into view. There are dozens of videos on YouTube showing this. Until the ship reaches the perceptual and perspective limit of the camera or telescope and goes totally out of view. This is perception limit, which gives seeming curved lines. The ship seems to be going over an apparent curved surface horizon. It's not. If the ship were going over a physical curve, you can't bring it back into view with anything. You must go higher. Number 8, to see beyond the limit of the eyes, binoculars, cameras, and telescopes, you must go higher. This is the reason why the sun can't never be brought back once it seems to have set, because of the height above the earth that you are. And you must go higher, in other words. Why? Because the higher one goes, the more one sees in expanded, broader view. On a flat plane, as you go up, the surface recedes, but not its view, nor horizon. The surface lets you see more up to the next perception limit of height. The limit is equal to the height or altitude at each point above sea level, and the further the distance of the horizon from you. So the horizon seemingly rises with eye level, and also for another reason. Also, this is easy to check. Get into an airplane at 35,000 to 40,000 feet up. Look straight out the window at 90 degrees. Not down, not up, straight out. The horizon will seem equal to your eye level. The pilot sees the same thing. This is to be continued on part 2, where we start from paragraph 9 all the way to paragraph 15. And I want to thank everyone for listening to part 1. Please go to part 2 and part 3. Have a good day